Hello, aspirants. Welcome to Fight Club. In this session, we look into India's first lithium ion battery plant and understand the key rechargeable batteries that UPSC often asks about. In September 2025, India took a giant leap in clean energy by inaugurating its first large scale indigenous lithium ion cell manufacturing plant. So, this facility is located at IMT Sona, which is in Gurugram, Haryana. It is under the PLI scheme for advanced chemistry cells. So, why does this matter now? Until now, India imports more than 80% of its lithium ion cells, mainly from China and South Korea. So, with this milestone, India has stepped closer to Atmanirbhar Bharat, strengthening energy independence, the EV ecosystem, and also the future technology leadership. Now, before diving deeper, let's quickly revise the basics. So, what is a battery? Basically, a battery is a device that stores chemical energy and converts it into electrical energy through electrochemical reactions. Basically, batteries are divided into two types. One is primary batteries and the other is secondary batteries. Primary batteries பார்த்தோம் அப்படின்னா they are non-rechargeable. For example, alkaline batteries and zinc carbon batteries. So இவங்களோட usage பார்த்தோம் அப்படின்னா we use them in remotes, watches and small devices. இதுவே secondary batteries பார்த்தோம் அப்படின்னா they are rechargeable. For example, lithium ion batteries, lead acid batteries, nickel metal hydrate batteries and also flow batteries அப்படின்ட்டு சொல்லலாம். ஸோ பேசிக்கலாக இவங்க பார்த்தோம் அப்படின்னா they are used in EVs, laptops and grid storage. So how does a battery work? So batteryல பார்த்தோம் அப்படின்னா it has two electrodes. One is anode which is negative and the cathode which is positive. So both are separated by an electrolyte that allows ion flow. So battery discharge ஆகும்போது electrons externally ஆனோட்ல இருந்து கேத்தோடுக்கு மூவ் ஆவாங்க. ஸோ திஸ் ப்ரொடியூசஸ் எலக்ட்ரிசிட்டி. இதுவே ரீசார்ஜபிள்ஸ்க்கு பார்க்கும்போது the process can reverse. Have a look at this table. It will connect the battery types, their anodes and cathodes in a way that's useful for UPSC. Now, let's have a look into the key parameters or UPSC relevant terms for batteries. The basic parameter is energy density. How much energy a battery can store for its weight is its energy density. Higher energy density implies lighter batteries that last longer on a single charge. The next one is power density. How quickly a battery can deliver energy is its power density. Higher power density implies faster acceleration and response in EVs or devices. The next is cycle life. Number of full charge discharge cycles before the battery loses significant capacity is its life cycle. Longer cycle life implies more durable and cost effective. Round trip efficiency. How much energy you get out compared to what you put in while charging and discharging is its efficiency. Higher efficiency implies less energy wasted, thus better performance for EVs and grid storage. Now, let's explore the major rechargeable batteries important for UPSC prelims. The first is solid state batteries. These batteries use a solid electrolyte, making them safer with no risk or fire risk. In the batteries பார்த்தோம் அப்படின்னா they are very light and also they have the highest energy density of all. Up to 350 watt hour per kg வந்து இங்கே பார்க்க முடியும். But they are still expensive and at early stages of production. Future EVs and high-end electronics are the target use cases. The next one is lithium-ion batteries. The backbone of modern energy அப்படின்ட்டு சொல்லலாம். Lithium ions shuttle between anode and cathode. So they balance the higher energy density with efficiency and fast charging. But இங்கேயும் வந்து சில risk இருக்கு. So they are prone to fire and also reliance on cobalt and nickel are challenges. An interesting fact is the 2019 Nobel Prize in Chemistry went to lithium ion pioneers, and yes, India now manufactures them in Haryana. The next type is sodium ion batteries. So இதோட mechanisms பார்த்தோம் அப்படின்னா lithium ionோட சிமிலராக இருக்கும், பட் sodium is abundant and cheaper compared to lithium. So கொஞ்சம் ஹெவியராக இருக்கும், but they are safer too. So it is great for stationary storage and emerging EVs. So imagine India sourcing sodium from sea salt for its future energy needs. Next is nickel metal hydride batteries. So lithium ion batteries ஓட compare பண்ணும்போது they are not too dense but robust and widely used in hybrid cars. For example, Toyota Prius. So they tolerate overcharging well and they are still used in medical devices. Lead acid batteries. So the oldest commercial battery அப்படின்ட்டு சொல்லலாம், because they are in use for over 160 years. So இவங்க பார்த்தோம் அப்படின்னா they are very cheap and fully recyclable. So ஹெவியாக இருப்பாங்க, but they are low in energy density, but they can still be used for car starters, UPS systems and solar backups. Finally is the flow batteries. So இவங்கள vanadium redox batteries அப்படின்ட்டு சொல்லலாம். So they store their electrolytes in external tanks. So இதனால they make them bulky but ideal for long use, large scale storage also. So with lifespan expanding 10,000 cycles, they are perfect for stabilizing solar and wind power அப்படின்ட்டு சொல்லலாம். Have a look at these quick UPSC pointers. Always remember these comparative trends. Energy density order wise பார்க்கும்போது solid state batteries top the list and others follows. Efficiency wise பார்க்கும்போது solid state batteries and lithium ion batteries tops the list. Cost trend analysis பண்ணும்போது lead acid batteries are the cheapest while solid state batteries remains the most expensive. Now, have a look at these PYQs. UPSC has already asked several questions on this theme. These questions prove why this topic is a high yield area for prelims. To sum up, Haryana's lithium ion plant is not just a factory, it's a strategic leap for India's EV ecosystem, energy security, and climate goals. Thank you for watching. Stay tuned to Fight Club for more UPSC relevant insights.